Dear children, a very happy morning to you all. Hope you people are keeping good and enjoying your online classes most successfully. And today we are going to take up the next topic in the spherical mirrors. Last week we started with the spherical mirrors and we have seen the types of spherical mirrors as convex and concave. And today we are going to see about the image formation by a concave mirror. How the image is formed for the different positions of the object and where is it formed and what is the nature of the image. All these we will discuss in today's class. Children, this is a diagrammatically skill-based question. Therefore, the drawing skills are required much here, and the basic rules for drawing the diagram is explained in this class. So, listen to the basic rules which are being told here and follow them strictly, and only when you follow these rules you will be able to draw the diagrams exactly and correctly. And you need not mug up anything in this diagram, only you should be aware of the basic rules. Okay, so let us go into the class. This slide is a revision of what we have done the last week. So the figure represents a concave mirror, and a concave mirror, you all know that the reflecting part will be inside the mirror and the outside surface is the hard surface, which is the non-reflecting surface. Now you see at the center of the mirror a ray or a line passes through it, and that ray, it is called as the principal axis. And the principal axis, you have three red colored dots. The dot which is on the mirror represents the pole of the mirror P, and to the left of it you find another red dot, and that represents focus, or we call it as principal focus. And the next one is the center of curvature. So we find that three dots, pole, focus and center of curvature, all of them lie on the principal axis. And when we see the distance between the pole and the focus, it is called focal length, and the distance between the pole and the center of curvature, it is known as the center of curvature, R. So when you draw the diagrams, you have to fix P, F and 2F in such a way that F is the midpoint of C and P. Here we have represented 2F as C. The 2F should be C. Okay, so F should be the midpoint of C and P. So when you choose this scale for the diagram, then all the diagrams will come automatically. This slide represents rule number 1 for drawing the ray diagrams. So usually a concave mirror, it has to be represented like this. The inner surface is the reflecting surface, and the convex mirror on the right is there where the outer surface is the reflecting surface. The rule number 1 says, observe the blue color ray of light. So the ray is parallel to the principal axis. So after falling on the mirror, it is getting reflected, and the reflected ray passes through F, that is the principal focus. So we can sum up the diagram like this. Any ray
which is parallel to the principal axis after reflection passes through principal focus. So this is a common rule wherever you draw the ray diagrams. If the ray is parallel, then the reflected ray must pass through principal focus F. So this is the same case in convex mirror also. The ray is parallel to the principal axis, and after reflection it passes through F. Here it is not actually passing through F because it has the reflecting surface outside. So the extension of the reflected ray passes through F. Okay, so this is rule number 1. This is rule number 2. The rule number 2 is the opposite of rule number 1. So rule number 1, we have seen that any ray which passes parallel to the principal axis after reflection passes through principal focus. Now you see the diagram, left side diagram, concave mirror. How is this first line passing through? The first line is passing through principal focus. And how is it getting reflected? Parallel to the principal axis. So the rule number 2 says, any ray which passes through principal focus is reflected parallel to the principal axis. Okay, any ray which passes through principal focus is reflected in such a way it is parallel to the principal axis. The same thing happens in the convex mirror also. So the ray passes through the principal focus, and after reflection it is parallel to the principal axis. The next rule says, any ray passing through center of curvature is reflected back in the same path. So the incident ray and the reflected ray for this case will be one and the same. So here there are two lines which passes through the center of curvature. So what happens after it strikes the mirror? It is reflected back in the same path. You can see the arrow marks, two arrow marks which are in the opposite direction. One is the incident ray, the other one is the reflected ray. So a ray passing through center of curvature is reflected back in the same path. Here is the last rule. Any ray which is oblique and passes through the pole of the mirror is reflected in such a way that the angle of incidence is equal to angle of reflection. So here above the principal axis there is a ray that we call it as incident ray. So it falls on the point P, pole of the mirror. So here is the reflecting surface at P. So it is reflected downwards. So the ray which is down the principal axis is the reflected ray. Thus it makes two angles with the principal axis. The angle above the principal axis is angle of incidence, and the angle below the principal axis is angle of reflection. So if a ray, this is a oblique ray. So if a oblique ray passes through the pole of the mirror, is reflected back in such a way that the angle of incidence is equal to angle of reflection. This slide gives you the heading of the diagrams which you are going to draw. There are 6 subheadings. So the total heading is formation of different types of image by a concave mirror. So what are the positions? First, between the pole and the focus, at the focus, between the focus and the center of curvature C. Then at the center of curvature beyond the center of curvature and at infinity. Now for all these diagrams, the basic rule is this. First you have to draw what you are seeing in this slide, the diagram. First you have to draw the concave mirror, shade its outer surface so that it reflects the light only inside. Then find the pole of the mirror and mark it as P. Then draw a perpendicular line that will be the principal axis. Then fix F and C. When you fix F and C, if you keep the distance between F and P 3 centimeters, same 3 centimeter should be the distance between C and F. Okay, you got my point? So first you are fixing the point P, then you are fixing the point F at a distance of 3 centimeter or 4 centimeter as you like. Then next fix the point C such that the distance between C and F should be 3 or 4 as you have kept before. So if you keep this distance equal, in short, F should be the midpoint of C and P. Okay, it should be exactly the center. F should be the exactly center of C and P. That means the distance CF should be equal to the distance FP. So you must take it in the scale or the ruler and fix the point F and C. This is the rule for every diagram that you are going to draw. Now here you find C, and when you keep the object at the beginning of the principal axis, and that position is at infinity or beyond C. Beyond C, okay. Then when you keep the object exactly at C, then that will be at C. When you keep it between C and F, that will be between C and F, and between at F and between F and P. Okay, so this is the different positions for which we are going to draw one by one. This is the first position. The object is at infinity. When the object is at infinity, so you get this diagram. So all the rays are parallel, and you have read in rule number 1, if a ray is parallel, then they get reflected, and all the reflected ray passes through principal focus. So the image is formed at F. And how is the size of the image? It's very pointed image. You cannot even see it, right? And it is real. If already we have seen what is a real image, the image, if it is formed on the left side itself, on the reflecting surface side, then it is real. So then inverted and point size. So these are the nature of the image. So this diagram represents the image formation for an object which is kept at infinity. So when the object is at infinity, all the rays are parallel. So all the parallel rays reflect and pass through the point F. So since all the rays are meeting at F, the image is formed at F. Okay, then here it is the quality of the image. It is first real. When the image is formed on the reflecting surface itself, it is real. Then it is inverted. Then it is point size. So these are the qualities of the image. So this is a very easy diagram. You can draw it. Now the image is placed beyond C. Now you observe the diagram. So P, the pole of the mirror, F, focus, C, center of curvature. So these are the position. First we have to draw the principal axis, then fix the point P, F and C. Now see the line AB. The line AB represents the object. Where is the object? It is beyond C, isn't it not? So it is beyond C. That's why we call this position as the object is kept beyond C. Now two rays you have to draw for the object AB. So where the object ends, so draw a parallel ray to the principal axis. So the parallel ray after reflection should pass through F. Okay, so it passes through F. The first ray diagram is completed. Second, you connect the B point with the C point. So that means the ray which is passing through the center of curvature is retracing its paths. So the incident ray and the reflected ray will be one and the same. So complete these two rays and observe where these two reflected rays meet or intersect. They intersect at a point A dash B dash or A1 B1. So A1 B1 is the image formed for this object which is at this height. So the image formed is real because it is formed on the left side, inverted and smaller than the object. Okay. This slide explains you the position of the object kept at C. So you can see the point C. So the line above, perpendicular line above OB represents the object. So it is exactly kept at C. Now as before, you have to draw the concave mirror, fix P, F and C. And when you are fixing up, F should be the midpoint as you know. Right. Now after this, draw the object OB above C. The same two rays we have to draw. So a ray from B should be parallel to the principal axis, and after reflection it will get reflected through principal focus F. So that is the first one. Second line, the second ray diagram, from the point let it pass through F. The rule number 2, any ray which passes through the principal focus is reflected parallel to the principal axis. So these are the two rays. Now see where these two rays are intersecting or meet. They will exactly meet at the point C below. So OB is the object, OG is the image. The height, when you measure the height, OB, it will be equal to OC. So we can say it is same size. And it is on the left side, so it is real. So it is a real inverted and same size image is formed in this position. This slide is explaining you for the position between F and C. So you see where F and C is in the diagram. So the green color up arrow represents here the object, and for this ray diagram also, first you have to draw the mirror, principal ray, and fix the point P, F and C. Now the object, you have to draw the perpendicular object in between C and F, anywhere in between you can take. As usual, you have to draw the two rays. One is the parallel to the principal axis, and after reflection it passes through the point F. Second, connect the height of the object with F. So a ray which passes through principal focus is reflected parallel to the principal axis. So check where these two rays meet. So they meet beyond C. So the image is formed beyond C and it is inverted and it is real because it is formed on the left side of the mirror. So it is real. So real, inverted, and look at the size of the object and image. The size of the length of the image is more. Therefore we say the image is magnified or enlarged. So real, inverted and enlarged image is formed. And where is it formed? Beyond C. This slide shows you the object which is placed at F. So at F itself the object is placed. So above F you draw just a line perpendicular to the principal axis and that will be the object. So you have to draw the ray diagram. As usual, let it be parallel to the principal axis and after reflection it will pass through principal focus. That is the first one. Second, join C and the point J, which is the top of the object. So any ray which passes through the center of curvature is reflected back in the same path. So where does these two rays meet? Obviously, these two rays seems to be parallel, but not parallel. They seem to be parallel. They perhaps will meet on the left side at a greater distance. Okay, so the image is formed at a very infinity distance, and so the nature of the image formed here is real because they are going to meet only on the left side, real, and it will be inverted and it will be a very enlarged image and it is formed at infinity. So this is the ray diagram for the object which is kept at F. This is the most important diagram of all the diagrams because this is the only diagram which you get the image on the right side. You see, when you look at the right side, you get the image. So the image here is virtual. As I told you, the image, if it is formed on the left side, reflecting side, it is real, and if it is formed on the non-reflecting side, that is on the right side, it is virtual. So the object here, it is kept between P and F. So OJ is the object. So for OJ, you draw the two rays. One is parallel to the principal axis. After reflection, passes through the principal focus. Now extend it on the right side also. So when you are extending, it should be dotted line. It should be dotted line. And join J and C. So because a ray which passes through the center of curvature retraces its path. So extend that line also. Both the extended rays meet at the right non-reflecting surface. So GI is the image. So how compare the height of the object and the height of the image formed. So it is enlarged. Since it is formed on the right side, it is virtual. Okay, virtual, erect. Here it is erect. And magnified image is formed behind the mirror. So this is a very important diagram, and this diagram is often asked in the board examination. So as usual, first draw the mirror, then draw the principal axis, fix the point P, F and C in such a way F is at the center. Then draw the object OJ in between F and P. Then draw the two rays one parallel to the principal axis and other through center of curvature. Extend it on the other side by a dotted line, so it will meet at the point G. Drop a perpendicular from G, and that is the image. Here in this slide, all the 6 positions are drawn in such a way that you can compare it. Now, it need not be the same what you have drawn, it can be even different, but as I told you, as I have explained you in each slide, you follow the same method, you will get it. So first infinity, then beyond C, then at C, then between C and F, then at F, and between F and P. So these are the 6 positions. So draw the ray diagram and complete it. So this, as an assignment, you have to draw in a 4-sheet paper all the 6 diagrams, and you have to write the nature of the image form. The nature of the image means whether it is virtual or real, whether it is enlarged or diminished, whether where is it formed. All this information gives the nature of the image. This slide gives you the nature of the image formed for all the 6 positions which you have seen earlier. So at infinity, what is it? The nature of the image. The image is obtained at the focus and highly diminished, real and inverted. So this also you have to write it in the A4 sheet paper for each of the diagrams. Children, we come to the end of today's learning process, and I have given you only a little. So as I told you in the beginning itself, this is a drawing skill based question. So you will get the answer only when you follow the rule. So for all the diagrams, again I am repeating you, draw the concave mirror as shown in the diagram, where the reflecting surface is on the left side and the non-reflecting surface is on the right side. Then fix the point P, the pole of the mirror, that is the center of the mirror. Then fix the point F and C. When you fix F, it should be the center of P and C. So when you follow these rules for all the diagrams, you will get the result fantastically. So take a A4 sheet paper. So divide it into 3 portions for the first page and for the second page. So where you can draw all the 6 diagrams neatly with the boundary with your name on the right side top corner. So this will be the assignment paper. So it will be valued or kept for the internal assessment, 20 marks. Okay children, so we will see next week with the continuation of the same lesson.